Think about the quiet devices in your home. Security researchers scanned thousands of smart TV apps, looking at innocent-seeming programs like that digital aquarium screensaver. Over a third contained hidden software silently routing strangers' internet traffic through your network. Researchers flagged over 2,000 apps across LG and Samsung platforms, trusted brands in millions of homes. These apps were designed to be non-intrusive, clocks, fish tanks, and simple games, to ensure users never suspected their network was being used as a commercial proxy gateway. The software is designed for persistence. If a user deletes the host application, the proxy software often remains embedded in the network, continuing to route traffic indefinitely. This pattern of invisible background activity extends into professional development environments. A recent defect in OpenAI's Codex Assistant revealed how even a standard coding tool can aggressively exhaust local hardware. This timeline compares a standard solid-state drive's expected lifespan with a defect found in Codex's telemetry system. A normal consumer drive is typically under warranty for about 600 terabytes of total data writing. Codex was silently writing 640 terabytes to local developer drives in a single year, effectively burning through the drive's entire warranted lifespan in 12 months. The root cause was a logging loop that persisted everything from raw payloads to internal events. The system only retained about 500,000 rows of data, but it had allocated over 5.5 billion row IDs, a 10,000 to 1 ratio of writing and deleting that occurred entirely in the background. Whether it's routing traffic on a TV or logging data on a developer's workstation, these background loops generate a level of physical churn that consumer-grade hardware was never designed to sustain. Researchers at Oxford, Stanford, and the LSE recently measured this same unyielding scale as it applied to human decision-making. They tracked nearly 19,000 conversations to see if modern AI models could change people's minds more effectively than elite human debaters. This chart displays the financial results of those interactions. Compared to professional canvassers from UK firms, the AI system secured nearly triple the amount of charitable donations. Even when the human experts were given time to research and offered £1,000 cash bonuses for their performance, the machines won. However, the researchers then applied a constraint. They throttled the AI to match a human typing speed and message length. When the machine was forced to communicate at our pace, its persuasive advantage disappeared completely. The models didn't win because they discovered more profound logic or better arguments. They won because they could provide instantaneous, personalized responses across a volume of conversation that no human expert could match. The human mind is being outmaneuvered by the same mechanism that exhausts our hardware, a relentless, unconstrained scale of operation. That velocity is now being deployed defensively to manage the code that runs our devices. Specialized models are actively scanning global open-source infrastructure, repairing security holes in real time before attackers can find them. Within its first week, the Patch the Planet initiative successfully merged 37 security fixes across 19 major projects, including the libraries that handle encryption and internet communication for most modern software. These systems work through continuous 24-hour loops. They are transitioning from being tools we use to being autonomous agents that maintain codebases without human intervention. To maintain this speed, they are using infrastructure like Oak, a Git alternative built specifically for agents. This chart shows the friction of human tools. Creating a code branch takes 10.5 milliseconds in Git, but only 7.5 in Oak. Over a 24-hour cycle of constant iteration, that difference adds up. We are reaching a point where these agents are no longer just operating within our systems. They are building their own optimized environments to work faster. The core libraries that allow our software to stay secure and functional are increasingly being rewritten by these loops, operating at a velocity that makes human oversight a secondary, slower process. While these systems appear increasingly transparent, the interfaces are often misleading. When a tool like Claude Code provides extended thinking, the user sees a human-readable list of logical steps. That text is not the machine's actual reasoning. It is a lossy summary designed for human consumption, a translation of a process that is far more complex than the interface suggests. The actual step-by-step logic is encrypted into 600-character signatures. This reasoning is not stored in a way that the user or an independent auditor can read. Currently, only the corporate developers of these models hold the decryption keys. This means that if these systems make a critical error in a regulated industry, there is no way for an outside party to verify the actual path the machine took to reach its decision. This lack of auditability is occurring as agents gain more autonomous capability, accessing private home networks, ingesting untrusted data, and executing commands in the dark. We are constructing a digital foundation where the physical hardware is being exhausted by background tasks, and the logic governing our software is being encrypted. We are building our infrastructure on an opaque stack, a system where the most powerful operations are the ones we are no longer permitted to see.